Hi and welcome to the Lecture 4 demo video. Hope everyone's doing well. Today we're going to start off with our DB file. And you might notice that we have two other Python files, app.py and DAO.py. We'll be going over those right after coding and db.py. So like our previous demos, we'll be making a backend that works with creating tasks and subtasks that refer to each task. We'll be using Flask SQL Alchemy, so if you watched the lecture video that Connor made earlier, we are abstracting away from using raw SQL-like commands, and we're going to be using an actual database to help us manage, laborious and tedious tasks like assigning IDs and stuff like that. So to get started, we're going to create a class called task. Now in SQL Alchemy, the way that you mention that this is a table is by telling it that it's a model. So that's why we're taking in db.model. We're going to add a column called ID. It's going to be an integer, and we're going to set primary key equals to true. This should be familiar from the raw SQL-like commands that we've been doing. And likewise for description, we're just going to have a column that's going to be type string. Nullable is false, which means that if a user is going to be inputting data, we're going to require that these fields must be filled out. So after defining what columns we want in the table, we have to create a constructor, because what SQL Alchemy does is for each new row that we add to the table, it's essentially an object that we have to initialize. So our constructor is just going to take in the column, info that we need. So description and done is all we need to be able to add new data to our table. So it's great that we can interact with the data as objects now, but we need to be able to return our data properly to our clients as JSON. So we have this Serialize method that basically interprets our column data per row as this sort of JSON format. So this is pretty standard. You should be familiar with this from the last demo as well as in the last assignment. Note that because we're representing a row or a piece of data in the table as an object, the way that we reference columns is by using self.id. It's kind of like in Java when you say this.id or this.description, you're saying that, okay, these fields belong to this object. Alright, so the next table that we need to create is the subtask table. Again, it's just going to be defined by parameter with db.model. We're just going to call it subtask, and like task is going to have the columns ID, description, and done. So this is the same order of business. We're going to mention that the primary key is true for the ID, so it's unique. We're going to say that description nullable is false, and as well as for done, this nullable field should also be false. So we're going to structure the relationship between a subtask and a task the same exact way that we've been doing it for the last demo. So you need to know the task ID for every single subtask, so it's a one-to-many relationship. And just as how you use foreign key in the SQL raw commands, here you're just going to call foreign key on this DB object, and it's going to be on the ID of the task column. So do note that if you call your Python class some different name, but you say that __ table name __ is lowercase task, then this would still work. It's just common practice that you would name your Python class the same as the table name. So just like how we created a constructor for the task table, we're going to be doing that for the subtask table as well. And for those who don't know, quargs is just some specific Python syntax which says that this method can take in any number of arguments. And don't forget that your constructor method needs to take in that task ID, because you can't just create, a floating subtask that doesn't belong to any other task. Now that we've created the constructor method, we're going to create the serialize method, which is the exact same thing as the serialize method of the task table. But now we have to go to the task table and let it know that it can reference subtasks as well. So not only does the subtask table have to know the task ID, the task class has to be able to have its own subtask field. And something that's new for SQL Alchemy that we didn't have for the raw SQL-like commands is this cascade keyword, which is saying that we are going to be able to cascade parent deletion down to the children. So in this example, subtasks would be the children and tasks would be the parent. So if we delete a task, then we can expect that all of its subtasks will be deleted as well. So now that we have added the field of subtask to a task, we should be able to add it to our serialization of the entire task object. And logically, it would follow that serializing subtasks would mean serializing each of those subtasks as to how they were defined in their own serialized methods. So now let's add something new. Let's add a class called category, which lets us categorize our tasks based on these certain colors. So for example, you might notice in your Mac, you can categorize your folders into like red, blue, or green. So we're going to be able to do that in this category class for our tasks. So similar to how we've been doing for our tables, task, and subtasks, we're going to have an ID and a description. And instead of a done field, we're going to have a color field. And just as any other SQL Alchemy model, we're going to have a constructor with quarks, and instead of description and done, we're just going to have description and color. The serialize method is pretty straightforward as well. It's the same, except we're just going to add color. But what does adding this new class called category even mean? So if you think about it, it's going to be a many-to-many relationship with tasks. So you can have many tasks under one color, and you can have a task have multiple colors assigned to it. So right now we're going to be creating a many-to-many relationship association table. So how you create that is by defining this new, table where you call it association. So instead of defining a class, it's just going to be a table that joins on two classes that already exist. So this db.model.metadata is kind of like, you can think about it as a class that can point this association table foreign keys to the classes that are trying to reference this association table to say, hey, okay, this task ID is going to be referencing this task table, and likewise this category ID for this category table. So it's basically serving as like a linker. And similar to how we added the field of subtasks, we're going to add a field of categories so that, for each task, we can know what categories it's under. And we have this secondary field to tell us to point to this association table, which will help us join on that many-to-many relationship. And that back populates is pretty important because it says that, okay, this is going to be a bi-directional relationship, which means that categories can reference tasks and tasks can reference categories. So if we're going to be adding a new column, we also have to update our serialize method so that when we're printing out what a task is, we also see what categories it's under. And just like for subtasks, we have to serialize a category by its own serialization method. And now we can go back to category to fully establish that bi-directional relationship by allowing it to show the tasks that a single color can reference. So again, we use the secondary field to help us reference that association table, and we also use back populates on categories. So that concludes working in our DB file. We can now move into this DAO file, which stands for Data Access Object. It just means that this is another layer for accessing data as objects. So it helps us with that abstraction layer again. So right here, we're importing all of those classes that we define in our DB file so that we can truly interact with our data as objects. So now we can continue on with our usual business of getter and setter methods, as you could probably call for our database. So the first one that we're doing is getting all tasks. So this is quite standard again, as we've seen this before in our last demo and in your last assignment. And it's become a lot easier because now we can just use those methods that we defined from a class that was helped by SQL Alchemy, and we've basically abstracted away from completely working with the database. So DAO just serves as this another layer that helps us with abstraction. Just like in any other method, we would just use the serialize helper method that's already defined in our DB file. So we don't have to worry about making things into JSON. And then as for our create tasks, we're going to create a DB object. So that's going to call our constructor. So if you remember that underscore underscore init method that we defined for each class, that is essentially helping us create this object. So it's just going to be a row in our table. And now the reason that we have two separate lines, one for adding and one for committing, is so that we can add multiple objects before we commit to our database. So this yields a better runtime. And in general, it's just better to separate and minimize race conditions, because the less commits you have, the less problems you could have with your database in that sense. So now we're going to create our method getting a task by an ID. And just like how we did in the last assignment, we'll be getting the task by doing a query that filters on its ID. And since this will return a list of objects, we just want the first result that comes out. And if this task is none or null, we want to return that. And otherwise, we want to actually return the serialize method of this object. The update task by ID method is also quite similar. We're going to get the task by filtering on its ID. If it doesn't exist, we're going to return none. And if the description and done fields that the client sends us are actually valid fields, then we're going to update our database task with these fields. And since our data is now objects, the way that we can update these fields is literally with a dot operator. So just like how you would do this in Java, for example, like the object dot the field. And now all you have to do is commit it, because we're done editing the object. So the last thing that we need to do with our task object is being able to delete it by its ID. So this is basically like getting it, except at the very last second you say db.session.delete that task. So now we can go on to creating a method that will help you create a subtask entry in our subtask table. So it's just going to be create subtask with the fields that you need. And just like how we created a new task, we're going to be initiating the subtask object from the class that we already defined in from db.py. And as usual, you would use dbSession.add, and then you would commit and return the serialization of this new object so that, it's recognized as JSON. So that's it for subtasks. Now we can move on to this category business. So we have to be able to either get or create a category. So we're creating a method for that. Basically what it's saying is if we don't have a category that already exists, we can create it and set it a color and just commit that to the database. So the whole point of having a category is so that we can assign it to a task, and categories are tasked by these cool colors. So we're going to have a method called assign category, which takes in a task ID. So first we have to check if this task even exists in our database. If it doesn't, we just want to return none. So here I'm just copying and pasting code that we've already been writing over and over again. And then we're going to get that category. So if it doesn't already exist, it will get created based on description and color that the user wants and sends, and then we'll basically just append this new category to the task existing categories. So like I mentioned before, this is just using the dot operator since task is an object and categories is that list that belongs to task. And this is pretty straightforward again because we're just going to serialize it. So that concludes working in our DAO file. Now we can move on to working in our app.py. So as you recall, this is where we're going to be defining how to get the client requests and route that to the database methods. So before we start, let's just make sure that we have all of our imports. And as you can see in our new starter file, we have a bunch of setup. Don't worry too much about this. This is just some syntax business of SQL Alchemy. And what is important is that you write these database methods in your route endpoints. And by that I mean, just as you've been doing in the other demo and the last assignment, you're going to call the methods that you already defined in your next data abstraction later, and that would be the DAO. And then for create tasks, this would be, you want to be able to get the fields that the user wants to use to create a task with, like the description and done field. So you call that create task method from DAO, and you return whatever the DAO method of create task did for you. Because if you recall, DAO returns the serialized version of the object that you created through the DB file. And we're casting a bool because that's just a string, and we want to make sure that Python recognizes this as a actual, true or false. And just as we've been doing before, we want to turn that success response that something was successfully created. Updating a task is just as trivial. We need to unpack whatever the client sent us with json.loads, get all of the information that we need, stuff it into our update task by ID method, and return whatever our DAO method is giving us, because that's, again, already the serialized version of the object that we just created. Deleting the task is almost the same as getting a task by ID, and again, making sure that you respond accordingly. Alright, so that was the last of interacting directly with the task class. Now we can try to create a subtask, and this just takes in a task ID as suspected, and again call that create subtask method from the DAO file. So if this feels like boring work, it means you're doing a good job, because that's the whole point of abstracting things out, so that, as you get past each layer, you're making sure that, okay, this file is designated to just do this one thing. So if all you're doing is unpacking whatever the client sends you and stuffing it into methods you've already written, that is the goal that you should be achieving. And now we're unpacking whatever the done and description fields that the client sent us. And here, especially, we got to cast that to a bool for done and return a success bounce if we actually created that subtask correctly. Now we can move on to the category route, and this is just assigning the category. Do note that I did not write at app.route, and you'll see later that I'll get an error if I try to hit that endpoint. So don't forget to specify your endpoint or your URLs so that Flask can know to direct what route to what method. And here again, we're just unloading what the client sent us and assigning a category based on the task ID, whatever the client sent in, and respond accordingly. So sending a failure response if that task doesn't exist. Now I'm just opening up my terminal. You can see I'm attempting to run app.py and it doesn't work because I actually just created my virtual environment for the first time, which means I have to install the requirements that were listed in the requirements.txt file, which we should have given you in the demo starter code as well. So now that I can successfully create an environment and run it, you can see my terminal spits out all the tables that have been created in this process. So let's go to Postman and try out our routes. So if you recall, getting all the tasks is the same thing as, just a backslash, and we can actually try adding tasks to our endpoint, and yes, that does give us the same result. And now let's try making a post request to create a task. And how we do that is go to body, select raw, make sure that we're clicking JSON, actually write the JSON post body, and that's just going to be description, blah, 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 and done, blah, blah, blah. In this case, I'm going to say description is, clean the house, and the done field is false because I don't clean my house. And we can go ahead and make that request and see, amazing, we have a response. And some cool thing is that you can actually show your response in Postman as JSON, so it's like all nice and formatted. So let's change from making a post request to a get request so that we can see, okay, our task has been added because I can see it when I try to get all tasks. We can also see if we can get a task by its ID. So as you recall, SQL Alchemy will make sure that our first item has ID of 1, so we can try to get 1, and then we can see that getting 0 task isn't found. Now let's make a post request to update the existing task that has ID of 1 and have the description just say clean house very fast instead of clean house. And now we're making a get request to see that, okay, our task has been updated when I try to see all the tasks that are in my database. Now we can try and see if deleting a task works. So that's done by getting the ID of the task and making that delete request. And indeed, it does work. And then if we try to get all tasks, we see that no task exists anymore because we just deleted that only task that we had. Alright, and since we kind of need to make a subtask later, let's add back our task by doing a post request to create the task. Since we already have that filled in our body with description and done, it's pretty easy. Just change from get to post, and now we just did get again to see if all the tasks existed. And then now we're creating a subtask, and the description is just going to be sweep floors because that's a subtask of cleaning the house. After we've created the subtask, let's see if it's actually been added in. So let's do a get request. And as you can see, wow, we have that subtask list and it has sleep force. So we're all good. Alright, so now that our task and subtask endpoints work, let's try testing out our category one. So as you recall, this also has a description, And it would make sense to like be tasks I love or tasks I hate, or like mindful tasks, stuff like that, and you attach a color for it. So I'm just saying that red is for happy, but you can do anything. So as I mentioned earlier, we get an error because I didn't specify the endpoint that this method should be catching it at. So it makes sense that we will be assigning a category at a endpoint that takes a URL parameter of the task ID, but also a client body, because we want to take in that description in color. And as you can see now, it works. Alright, so that concludes our demo. Hopefully you guys have a less harder time on this assignment, and always let us know on Piazza if you have any questions. Good luck!